Today we are learning about forces. No, not the force, but we are talking about the forces that we experience every day. Also super cool, but less supernatural. So what is a force? We have both contact forces and field forces. Contact forces happen when two objects are touching each other or are connected by a rope. Field forces happen when two objects are impacted by each other without touching. Today we will discuss four of the most common forces: force due to gravity, normal force, tension, and frictional force. All objects experience the force of gravity pulling them towards the center of the Earth. The force due to gravity for each object is calculated by multiplying the object's mass in kilograms by the accepted acceleration due to gravity, which some nice physicists have established is equal to 9.8 meters per second squared. This relationship is also known as the weight of an object. The force of gravity is always measured from the center of mass of an object. This means that whenever we have a uniform object, which is one where the mass is evenly distributed throughout, the force of gravity is drawn from the very center. What I have started drawing here is a free body diagram. This is a tool that is very helpful when solving forces problems. Thankfully, it takes little to no artistic skill. Now each force is a vector quantity. It has both a magnitude and a direction. We know that each action has an equal and opposite reaction, thanks to Sir Isaac Newton's third law. Therefore, two forces that are equal in magnitude but point in opposite directions are known as force pairs. So, when we have a puppy sitting in my lap, the puppy applies its force of gravity to my legs, and therefore my legs must apply an equal and opposite force onto the puppy. This force is known as normal force. Normal force is drawn from the point of contact through the object to which it is applied. So next, I can take my puppy for a walk. If my puppy decides he would rather sit in the shade than continue walking, I might tug on the leash to let him know that I want to get moving so I can go watch some Netflix. In this circumstance, my puppy experiences two new forces. First, he experiences friction that opposes his motion. While the puppy does not move, he experiences what is known as static friction. If the puppy begins to slide in the direction that I'm tugging, he would experience what is known as kinetic friction. Second, the puppy experiences tension from the leash. The tension is a diagonal force, so I'll say that I tug the leash at an angle that we will call theta. This is where trigonometry comes in. We must break the diagonal force of the tension into horizontal and vertical components. Utilizing Sir Isaac Newton's second law, F equals ma, or the sum of forces equals mass times acceleration, I can see that the puppy is in equilibrium. Because the puppy is not moving, he experiences no acceleration, and therefore the net force is equal to 0 in both the x and y directions. This shows me that t cosine theta is equal to friction. I can also see that normal force plus t sine theta is equal to the force of gravity. In this situation, the upward force of tension will minimize the normal force experienced by the puppy. So now that you know all about forces, take a look around and instead of smelling the roses, contemplate the force of gravity pulling them to the center of the Earth.